Hello, so today we are going to move to chapter 15, and there are three parts, chapters 15A, B, and C, and we will break it up into smaller chunks, and today we're going to just introduce a normal distribution. So what makes something have a normal distribution? Well, it's because we have what we call a continuous variable, and you can't take a real value sometimes because of a measurement or something that's being rounded. And so we have what we call an interval. And that probability is going to get exactly something, is going to be zero. So we have continuous variables, and to find those probabilities, it's going to fall within what we call an interval. So, for example, if I say find the probability that an egg weighs exactly 72.9 grams, well, that is zero because we are weighing an egg, and we know that whatever scale we use to measure that egg, it is going to round it. So if, let's say, we were using a scale that measures the egg and it rounds to the nearest 0.1 grams. So to get 72.9, that weight is going to either fall between 72.85 and 72.95. Anywhere between there would round to 72.9. So because of that, to get exactly 72.9, it is zero. And we must, if you think about the words between 72.85 and 72.95, that right there is an interval. So anything that falls within that, that's going to be our probability. And the probability to get exactly 72.9 is zero. Like, that's impossible for that to really happen. So when we think about the probability, so the probability of us getting x to be exactly x, that's going to be zero. So for example, the probability of us getting exactly 72.9, that is zero. So we cannot use what we call probability mass function. A probability mass function is the functions that you guys are used to. What's the probability of getting exactly a 6 when you roll a die? Well, that's 1/6. That's a mass function. But because of the weight and the interval piece of it, we now will be using what we call a probability density function. So it's not a probability that we normally think. For example, the probability of getting a 6 when you roll the die. That is what we normally think of when we think about probability. But instead, this probability density function is going to be the probability of the area under the curve. So, for example, here is a diagram. Imagine that C and D would be our 72.85 and 72.95 in the previous egg example. The probability of that, getting that 72.9, falls between those two parameters. And so all of that shaded region right there is going to be your probability, whatever that percentage may be. So what probability density function are we going to look at? Well, we are going to look at what we call the normal distribution. And what makes it a normal distribution is the fact that it is symmetrical and it is a bell shape. If it is not both of those, it is not a normal distribution. So you could be symmetrical and not bell shaped, then it's not going to be a normal distribution. You have to have both of them in order for it to be normal. So then what makes something a normal distribution? Well, it's because it has many different factors that affect that value. So, for example, if you think about an apple orchard, somebody who owns an apple orchard, when you go to sell those, you sell them by weight. And think about when you go to the store and you buy a bag of apples. All the apples are different sizes, different shapes, and they all weigh different amounts. So why is that? Well, there could be multiple different things. You could have genetic factors. You could have the soil that the apple tree is in that would affect it, the amount of sunlight that the tree has, weather conditions. All of those are going to be factors into what the weight of that apple is. And so You're going to have an average weight, but then you're going to have some apples that are going to be heavier and some that are going to be lighter. That's just what the purpose of average is. You're finding what that middle ground is. So knowing the average is going to be important when we talk about normal distribution. So let's look at some curves here and let's determine which ones are going to be normally distributed. Well, if you look at example A, I could draw a line of symmetry right there, but it's not really identical. So does it have a bell-shaped? Yes, but it's not symmetrical, so A is not going to be normally distributed. If I draw that line on B, it is the same on both sides, so B is going to be normally distributed because it has the bell shape, but it also is symmetrical. On C, I could draw the line of symmetry, and it is the same on both sides, but the problem is it's not a bell-shaped. So C is not going to be normally distributed. If you draw the line of symmetry, oops, that should go in the center, sorry. On D, it is symmetrical, and it does have that bell shape, so D is also normally distributed. If you look at E, when I draw that, it's not identical on both sides. So it does have that bell shape, but it's not identical. So it's not symmetrical, which means it's not going to be normally distributed. And then F is going to be the same on both sides, and it has that bell-shaped curve, which means F is normally distributed. So in this particular problem, B, D, and F are all normally distributed, where the other ones do have a curve to them, they're just not normally distributed. Okay, so let's think about some examples, and let's determine what factors are going to take in place to make it normally distributed. So in this case, it says the amount of time a student takes to walk to school each day. How is that going to be normally distributed? Well, what are factors that would make this happen? Okay, so the amount of time, distance from school, is going to affect the amount of time. The further you live, the longer it's going to take. How about the speed? If I walk fast, it's not going to take as long as if I walk slow. Your physical ability. If I am not physically in shape, I'm going to get tired and I'm going to end up walking slower, which then will affect the time it takes for me to get to school. How about like the terrain, or terrain, I should say. Sorry. If there's a lot of hills, it's going to take me a little bit longer than if it was all flat. So because there's multiple different factors, that is making this type of situation a normally distributed problem. Let's look at some others. So here we want to determine whether it is normally distributed or not, and then sketch a graph that may be a possible distribution for this variable. Okay, so we're talking about the number of children in families in a city in Wales. Well, most families have between 0 and 2 kids. But then you can't have negative kids, and you can have more than 2, but the amount of families that have more than 2 kids are probably much lower. So this is not really going to be normally distributed. So I could draw we could have this where we have 0 kids, 1 kid, 2 kid, 3 kid, 4 kid. And this is like the number of families. So, in thousands, let's say there's 1,000, 5,000, 10,000. I don't know, I'm just making up numbers here, but we could have 5,000 families have 0, and 10,000 families have 1, and 9,000 families have 2. But then as we get to 3 and 4, we could easily see only 1,000 and then almost no families having 4 kids. So this is not a normally distributed problem. Example 2, it says the amount of time passengers spend waiting in a queue at the airport. Well, if you think about if you've ever flown before, they are going to try their best to get you out of that line as quick as possible. So in peak times, they're going to have probably more stations open so that they can get those people through fastly. So because of that, this is not going to be normally distributed. Because they're going to try and serve the people as quickly as possible to get them in and out. So this particular graph will look something like this. Like the more people you have, the quicker it's going to go. So not a normally distributive situation. The next one, it says scores for an ACT test. This one will be normally distributed. That should just be an I there. Sorry. So why? Well, it's because there's multiple different things that will affect your score. The ability level. The more content you know, most likely, the better you're going to be. The amount of time you spent studying. Time is going to be a factor. If you don't study at all versus if you spend a lot of time reviewing, you're probably going to get a better score. Your sleep, that could affect. If you get no sleep the night before, you could be very tired and then you can't function properly, and then your score could reflect that. So because there's multiple different things that could affect your score, we have a normally distributed curve. That should be the same on both sides, sorry.